Hey, so today we are solving daily Leetcode problem, neighboring bitwise XOR. But before that, thank you so much on the first video, which was where we discussed the previous problem, the previous day problem to this. I wasn't expecting much because that problem already came out, all the solution video came out already one day late, so I wasn't expecting much. But I guess the most funny part was when it reached one of my friends who doesn't even has computer science, and they commented that they didn't understand anything. Of course, you're not gonna understand anything. You're not from computer science. This is the stuff we do. Anything. Let's go back to the problem. Given if you have already solved previous day's problem, this problem should ideally be easy because it uses the same pattern that we use for the previous problem as well. Um, but let's just go to the problem and then we'll go to the pattern observation and how to tackle these type of problems in the end. So a zero index array derived with length n is derived from computing bitwise XOR of adjacent values in a binary array original length of n. Specifically for each index, this if n minus 1, which is the end index, is basically the last index and the first index. Basically, they are in a circular motion. So if you have an array 1, 2, 3 with these elements, so value for the new derived array is going to be calculated using these two, the next these two, next these two, next these two, and when you have reached the end, for calculating the end value, which is going to come here, you just go back to the first one to calculate the one. So it's a circular motion. That's what it's saying. So otherwise it's just like first and the next one, which I already mentioned here. So given an array derived, which has been derived like this, you need to find out if there is a possible original array for this problem. An example is also given to us here as well, where the derived array is 1, 1, 0, and the answer is true because there is an array 0, 1, 0 through which you can derive 1, 1, 0. Let's just see how. So you take XOR of 0 with 1, you get 1. You take XOR of 1 with 0, you get 1. You take XOR of 0 with 0 because it's the end index, you get 0. So we have one of the solutions to this problem, and hence we return true because it is possible to construct this array. Now, in the beginning of the video, I did mention that this should be ideally considered easy because it uses the same pattern as we did in the last video. I'm probably gonna like link it down in the description as well so that you can watch it, because that where we discuss the actual intuition and logic behind solving of that problem. But I'm gonna discuss it here as well just for complicity's sakes. So XOR, let's just discuss what basic XOR is. So if you have inputs of 1, 0, you get 1. You have inputs of 0, 1, you get 1. You have 0, 0 as input, you get 0. You have 1, 1 as inputs, you get 0. The only point here noteworthy of noting is if you have different inputs, where you see in this case you get 1. If you have same inputs, which are here 0, 0 and 1, 1, you get 0. That's the only thing that we need to note here. Also, so this also leads to identity as well. So any element you XOR with itself, you're gonna get 0. And this is what we used in the previous problem as well of bitwise XOR, where we use this property to calculate the final answer for us. This is where we are going to use simply the same property here as well. Also, it is also hinted from the constraints as well that n can reach 10 to the power 5 of length. So given this constraint to us, it's understandable to me that the final algorithm can reach n log n at max. So of course this means that O of n algorithm should work as well, and O of 1 algorithm should work as well. But any algorithm which has complexity of a n log n after this will not work because you're going to get TLE. Where I have one similar video as well where I discuss on how just looking at the constraint you can know which type of algorithm you should be thinking about. It helps break down the problem much more easier and gets the solution very easier as well to code and think about. But in this case, we are going to discuss an O of n solution, which is one iteration of the array. Okay. So the intuition behind the previous problem was, given an array, the intuition was that if you multiply the same, not multiply, but XOR the same number with itself, you get 0. Basically, this is an identity. So imagine you're given a derived array and you need to find out if there is a possible value of the original array for it as or no. So there is a property here that if you have already known this, that there is an identity existing, you can actually correlate like this. Given an original array A, B, C, so what the derived array would look like is, so you would have the first value coming as A XOR B. So you have AB, I'm representing XOR as AB. The second value coming as B XOR C, you have BC. And the next value coming as the last index and the first index, which is CA. Now observe carefully that there, and now observe carefully that if you XOR all of these together, you get 0. Why? Because A is gonna pair up with A, B is gonna pair up with B, C is gonna pair up with C. So given a derived array as an input to me, if I XOR all the elements together, I know that it is a valid derived array that should have an answer, that should have an original array. So given this identity of XOR, which I'm going to code as well because it's just like 3-4 lines of code. So it gives us an intuition of how XOR problems are being solved as well in an optimized way. Most of the time, you're just using the identity that if you XOR the same value with itself, you get 0. Basically, this is an identity. I need to like think of patterns here and there to get to the final answer. So I already discussed this like in the previous video as well. I'm going to link all the linking videos down in the description and in the I as well, somewhere here. I'm going to later figure that out. Let's just code for the time being. It's a simple code. Okay. So let's just code it out. So I'm gonna have the total XOR in a variable here. So I'm gonna take the first value as the default. Now I'm gonna start iterating from the second value because it's already given that the constraints are, you have at least one element in the array. So I'm comfortable taking this first element here. So I'm gonna start from the second index and I'm gonna start iterating the array. So I list in the size of the array. Okay, can't type properly, I guess. Okay. The size of the array, and I'm just gonna XOR each element with the previous XOR. Now I have the XOR of all the elements in this variable after this loop gets completed. Now we need to check if XOR of total all elements is 0, that we already discussed, because it's going to be identity, and it means that the derived array is valid. It came from an actual input, which we need to like output here as well. Does a valid array exist? If they have, by the way, it should be t here, I guess. Then if the array is valid, you return true. That means an original array does exist. And if not, then return false. That means it's just a fake array that was given to us, and it doesn't have an original XOR input array, which we can translate back to. I think this should be it. Let's just try to like run this. Okay, there's a syntax error here. Okay, I think this needs to be changed. Okay, yeah. So I'm just gonna submit this and it's gonna work. Okay. Let's just see the submit as well. Yeah, it got accepted and the solution is right. Okay, so that was just about it. Okay, see you in the next one, and hope that this gives the gist of how XOR problems needs to be solved as well. Just